In 2003, Boeing made the most expensive bet in the history of commercial aviation, not on a bigger airplane, not on a faster airplane, on a material, carbon fiber, a substance most airlines had never touched, a substance no one had ever wrapped around a passenger cabin at this scale. Boeing bet $32 billion that plastic could replace metal, that composites could replace aluminum, that everything the industry knew about building airplanes was wrong. That's not confidence, that's a leap of faith with a price tag. But this wasn't just about a new material, it was about a completely different vision of how humans would move across the planet. While Airbus was building the biggest airplane ever made, Boeing was building the most efficient one. One company looked at the future and saw more passengers. The other looked at the future and saw more routes. Only one of them was right. To understand why the 787 exists, you need to understand the world it was born into. The early 2000s were brutal for airlines. Fuel prices were climbing. 9/11 had gutted passenger confidence. Legacy carriers were bleeding cash, and the long-haul fleet was aging fast. The backbone of international flying was a collection of gas-guzzling widebodies. The 767 was tired, the 747 was expensive, the A340 was underpowered, and airlines were stuck in a model that hadn't fundamentally changed in decades. You flew from hub to hub, New York to London, Tokyo to Los Angeles, Chicago to Frankfurt, big airports connected to big airports by big airplanes. If you lived in a secondary city, you connected. You always connected. Here's the problem with that model. Connections cost money. Every hub transfer means gate fees, ground handling, delay risk, and lost passengers who'd rather drive than deal with a layover in Philadelphia. Airlines didn't want bigger planes to stuff more people through fewer hubs. They wanted smaller, efficient wide bodies that could fly point to point. Austin to London, direct. Perth to London, direct. Nairobi to New York, direct. Routes that couldn't fill a 747 but could absolutely fill a 240-seat airplane if the economics were right. The industry needed something that didn't exist, not too big, not too small, incredibly efficient, just right. And across the Atlantic, Airbus made the opposite bet entirely. They looked at the same data and concluded the future was about size, about moving 550 passengers at once through mega hubs like Dubai and Singapore and Heathrow. They poured billions into the A380, the largest passenger airplane ever conceived. A double-decker giant so enormous it needed airports to rebuild their gates just to board it. Boeing looked at the A380 and said, no, the future isn't about moving more people through fewer doors, it's about opening more doors. The 787 wouldn't just be a new airplane, it would be a new philosophy. But here's the nuance. Boeing didn't just need to build a better airplane, they needed to build a completely different kind of airplane. And that meant throwing away 70 years of construction knowledge and starting from scratch. Boeing first unveiled the concept in January 2003 under the name 7E7. The E stood for efficiency. It was the first signal that this wasn't going to be a traditional Boeing project. By April 2004, all Nippon Airways placed the launch order, 50 aircraft. The starting gun had fired, and within months, the order book exploded. Hundreds upon hundreds of orders before the airplane had ever left the ground, the most pre-ordered commercial aircraft in Boeing's history. Airlines loved the pitch, passengers loved the promise, and Boeing's marketing machine went into overdrive. But Boeing had a problem, a big one, and it had nothing to do with aerodynamics. Let's talk about what made the 787 revolutionary, not incrementally better, revolutionary. Every major commercial airplane before it was built essentially the same way. You take sheets of aluminum, you cut them, you rivet them together, thousands of sheets, millions of rivets. It's a process that dates back to the 1930s. The 777 used composites for about 12% of its structure, respectable for its time. The 787 pushed that number to 50%. By weight, half of this airplane is carbon fiber reinforced polymer. The fuselage isn't built from thousands of aluminum panels. It's built in massive one-piece barrel sections. Imagine a giant tube of woven carbon fiber cured in an autoclave the size of a building. No rivets, no seams, no corrosion points. Why did this matter? Because aluminum corrodes, it fatigues, it cracks along rivet lines after thousands of pressurization cycles. Every time an airplane climbs to cruising altitude, the cabin pressurizes. Every time it descends, it depressurizes. That's one cycle. Over 20 or 30 years, those cycles add up. Aluminum gets tired, composites don't, not the same way. To put that into perspective, a traditional aluminum fuselage might have over 50,000 fasteners in a single barrel section. The 787's composite barrel sections eliminated tens of thousands of them. Fewer fasteners means fewer potential failure points. Fewer failure points means less maintenance. Less maintenance means lower costs. Lower costs means cheaper tickets. That's the cascade effect Boeing was chasing. But composites gave Boeing something else. Something passengers actually feel. Because carbon fiber doesn't corrode, the cabin can be pressurized to a higher equivalent altitude. Traditional jets pressurize to 8,000 feet equivalent. The 787 pressurizes to 6,000 feet. That difference sounds small on paper. In your body, it's enormous. Less fatigue, fewer headaches. You land feeling like a human being instead of a dried-out husk. Then there were the windows, the largest ever put on a commercial jet. No plastic pull-down shades, electrochromic dimming. You press a button and the window tints from clear to dark blue. Humidity in the cabin is notably higher than on older jets, reducing the dehydration effects passengers typically experience on long flights. LED mood lighting simulates sunrise and sunset to help reset your body clock on long flights. This wasn't just engineering, it was an experience. Boeing wasn't just selling an airplane to airlines, they were selling a feeling to passengers. And the engines. Two choices, the Rolls-Royce Trent 1000 or the General Electric GEnx. Both were next-generation turbofans designed specifically for this airframe. To put that into perspective, the engine diameter on a 787 is so large you could nearly fit the fuselage of a regional jet inside the nacelle. These power plants delivered 20% lower fuel burn compared to the aircraft the 787 was replacing. Let's talk numbers. 20% fuel savings doesn't sound dramatic until you multiply it across a fleet. A single long-haul flight burns tens of thousands of pounds of jet fuel. 20% of that is thousands of dollars per flight. Multiply by 2 or 3 flights per day. Multiply by 365 days a year. Multiply by a fleet of 50 aircraft. Airlines weren't buying an airplane, they were buying a money printing machine. But the best was yet to come, or rather, the worst. Boeing made one of the most consequential decisions in modern manufacturing history, and it nearly destroyed them. Instead of building the 787 the way Boeing had always built airplanes, primarily in-house with tight control over every rivet and wire, they outsourced roughly 70% of the aircraft's structure to a global network of partners scattered across a dozen countries. The forward fuselage came from Spirit Aerosystems in Wichita and Kawasaki in Japan, the center fuselage from Alenia Aeronautica in Italy, the wings from Mitsubishi Heavy Industries in Japan, the horizontal stabilizer from Alenia in Italy, the vertical tail from Boeing in Frederickson, Washington. These massive sections were then flown to Boeing's assembly plant in Everett, Washington, aboard 4 specially modified 747 freighters called Dreamlifters. These are some of the most bizarre-looking aircraft ever built. A 747 with a bulging fuselage and a swing tail that opens like a clamshell. Only 4 exist in the world. The plan was elegant on a whiteboard. Partners would invest their own money. They would deliver completed, ready-to-join sections. Boeing would snap them together in a final assembly process that was supposed to take 3 days. 3 days, like assembling furniture from a flat pack, except the furniture weighs 400,000 pounds and carries 240 human beings at 500 miles per hour. Why did Boeing do this? Because the financial logic was seductive. Risk-sharing partners would shoulder development costs. Boeing's upfront investment would shrink. The program would come in under budget and ahead of schedule. That was the theory. The reality was a catastrophe. Many of these suppliers had never worked with composite materials at this scale. Parts arrived at Everett incomplete, out of specification, with temporary fasteners still installed where permanent ones should have been. Wiring harnesses didn't match. Software integration was a nightmare. Some sections simply didn't fit together. Boeing had built a global supply chain so complex that when one link failed, the entire chain seized. But here's the part that still haunts the company. Boeing didn't just outsource manufacturing, they outsourced knowledge, institutional expertise that had taken decades to accumulate. The engineers who understood how a fuselage section interfaces with a wing root, the technicians who knew how to route wiring through composite structures. That knowledge walked out the door and into supplier facilities in Italy and Japan and Kansas, and when those suppliers hit problems, Boeing didn't have the in-house expertise to diagnose and fix them quickly. The 787 was originally supposed to fly in August 2007 and enter service by May 2008. Neither happened. The program suffered 7 formal schedule delays. 7. Each one sent shockwaves through the industry. Boeing's stock cratered. Airlines scrambled to cover gaps in their fleet plans. The first aircraft assembled, known as ZA001, was so overweight and so full of non-standard parts that it could never be delivered to a customer. It became a permanent test aircraft, a $250 million paperweight. Boeing dispatched hundreds of engineers to supplier facilities around the world, firefighting, fixing problems that partners couldn't solve. The company was essentially reverse outsourcing its own program. The first flight didn't happen until December 15, 2009, over 2 years late. The first delivery to all Nippon Airways didn't happen until September 25, 2011, more than 3 years behind the original schedule. To put that into perspective, the total development cost ballooned to approximately $32 billion. The original budget was $10 to $12 billion. Boeing had spent 3 times what they planned on an airplane that was supposed to save money through outsourcing. The program became a case study taught in every business school on the planet. What happens when you treat aerospace manufacturing like a spreadsheet exercise? What happens when financial logic overrides engineering judgment? But the 787's nightmare wasn't over, not even close. The airplane entered commercial service on October 26, 2011. All Nippon Airways flew the inaugural route from Tokyo Narita to Hong Kong. Airlines praised the fuel efficiency. Passengers raved about the cabin. The order book kept growing. For about 14 months, it looked like the 787 had finally turned the corner. Then January 2013 happened. On January 7th, a Japan Airlines 787 parked at Boston Logan Airport caught fire. A lithium-ion battery in the auxiliary power unit experienced thermal runaway. No passengers were aboard, but the fire burned through the belly of the airplane. The images were devastating. A brand new Dreamliner with smoke pouring from its underside. 9 days later, an all-Nippon Airways 787 made an emergency landing in Takamatsu, Japan. The main battery in the forward electronics bay began smoking during flight. Passengers were evacuated down emergency slides on the tarmac. On January 16, 2013, the FAA issued an emergency airworthiness directive grounding the entire worldwide 787 fleet, every single one, about 50 Dreamliners with 8 airlines, grounded. This was the first time the FAA had grounded an entire aircraft type since the McDonnell Douglas DC-10 in 1979. That's 34 years. Let the weight of that settle. Why was this so serious? Because the 787 was the first commercial aircraft to use large lithium-ion batteries as a core part of its electrical architecture. Boeing had replaced many traditional hydraulic and pneumatic systems with electrical ones, a concept called the more electric aircraft. Brilliant in theory, but it meant those batteries weren't backups, they were critical systems. When they failed, the airplane had a fundamental problem. The batteries were manufactured by GS Yuasa of Japan. Investigators found that an internal short circuit in one cell caused thermal runaway. One cell overheats, the neighboring cell overheats, chain reaction, fire. Boeing's fix took approximately 3 months. They encased each battery in a new stainless steel containment box designed to contain any fire or thermal event and vent fumes outside the aircraft through a dedicated tube. Additional insulation between cells, enhanced monitoring, improved charging protocols. The FAA approved the fix. The fleet returned to service in late April 2013 after a grounding of approximately 3.5 months. No passengers were harmed in either incident. But the reputational damage was enormous. The airplane that was supposed to represent the future of aviation had been parked on tarmacs around the world because its batteries caught fire, and the financial bleeding continued long after the fleet returned to the sky. Boeing uses a program accounting method where early production costs are spread across a large block of aircraft. For the 787, that block was originally 1,100 units. This creates something called deferred production costs, money Boeing spent building early airplanes that exceeds what customers paid for them. The assumption is that later airplanes in the production run become cheaper to build, and the profits offset the early losses. By 2015, the 787's deferred production cost balance peaked at approximately $28 to $29 billion, the largest deferred production balance in Boeing's history. Boeing was losing millions of dollars on every early Dreamliner it delivered. The company gradually ramped up production, reaching 12 aircraft per month by 2019 across 2 factories, Everett and North Charleston, South Carolina, with plans to push even higher. The per-unit costs came down. Boeing said the program crossed into per-unit profitability, but most independent analysts believe the overall program, when you add up every dollar spent since 2003, may never fully recoup its investment. The stakes couldn't be higher, because even that wasn't the end of the 787's troubles. In 2020 and 2021, Boeing discovered manufacturing quality issues on the production line. Tiny gaps near the joins of fuselage sections, fractions of an inch. In most industries, nobody would notice. In aerospace, where a fuselage must withstand tens of thousands of pressurization cycles over decades, tolerances are sacred. Fractions of an inch can mean the difference between a 50-year service life and a catastrophic structural failure. The problems were systemic, both the Everett and North Charleston factories. Some issues reportedly dated back years, shimming that wasn't documented, inspections that weren't completed. The FAA effectively halted 787 deliveries for much of 2021 and into 2022, a period spanning well over a year. During that time, Boeing kept building airplanes it couldn't deliver. At one point, over 100 completed Dreamliners sat parked at Boeing facilities, each one worth tens of millions, each one generating zero revenue. The delivery halt reignited concerns about Boeing's corporate culture that had been building since the 737 MAX crashes of 2018 and 2019. Whistleblowers came forward. Former employees alleged that quality inspectors were pressured, that problems were downplayed, that production speed had become more important than engineering rigor. This is where the 787 story intersects with a much larger narrative about what happened to Boeing as a company. In 1997, Boeing merged with McDonnell Douglas. On paper, Boeing acquired McDonnell Douglas. In practice, many industry observers argue that McDonnell Douglas's management culture swallowed Boeing from the inside, a culture that prioritized financial performance and shareholder returns over Boeing's traditional engineering-first identity. The 787 was the first major all-new aircraft developed under this new philosophy. The outsourcing strategy, the aggressive timeline, the risk-sharing partnerships, the relentless pressure to minimize upfront investment, all of it reflected a financial strategy wearing an engineering costume. When the program collapsed into delays and cost overruns, it exposed the limits of managing an aerospace program like a quarterly earnings report. The lessons of the 787 are now regularly compared to the 737 MAX crisis. In both cases, critics argue Boeing prioritized schedule and cost over thoroughness. The difference is that the 787's failures were financial and reputational. The MAX crashes killed 346 people. But here's the interesting part. Despite everything, the delays, the batteries, the quality scandals, the billions in cost overruns, the 787 is one of the most commercially successful wide-body aircraft ever built. As of 2024, Boeing has received well over 1,800 orders from more than 75 airlines. Over 1,100 have been delivered. The airplane fundamentally changed how airlines think about their networks. Before the 787, if you wanted to fly long-haul, you needed a big airplane. A 777, a 747, 300 to 400 seats minimum. That meant you could only fly routes with enough demand to fill those seats. Hub to hub, the 787 shattered that budget constraint. Suddenly, airlines could open thin routes, city pairs that couldn't support a jumbo but could absolutely sustain 200 to 300 passengers in a fuel-efficient widebody. The routes the 787 created read like a revolution in global connectivity. Austin to London, Perth to London. Qantas flew that one on a 787 and it became a record-setting service. Nairobi to New York. Ethiopian Airlines used 787s to connect Addis Ababa to cities across Africa, Asia and the Americas, transforming itself into one of the world's fastest-growing carriers. Norwegian Air used the type for low-cost transatlantic service. United Airlines built its entire long-haul strategy around it. The airplane comes in 3 variants. The 787-8 seats about 240 in 2 classes and flies over 7,300 nautical miles. The -9 stretches to about 290 seats with a range of roughly 7,530 nautical miles. It's the best seller, the bread and butter. The -10 is the longest variant, seating about 330 passengers, but with a shorter range of roughly 6,300 nautical miles. It's optimized for high-density routes where range isn't the priority. Why did this matter? Because for decades, airlines had a Goldilocks problem. The 767 was too small and too old. The 777 was too big for many routes. The 787 sat right in the middle, just right. Now, here's the black sheep, the 787-10. On paper, it makes sense. Bigger cabin, more revenue per flight, but it sacrificed range. And in the wide-body market, range is king. Airlines that wanted a bigger airplane with long legs looked at the -10, looked at the range penalty, and ordered the A350-900 from Airbus instead. The -10 found buyers, particularly in Asia, where high-density medium-range routes are common, but it never achieved the runaway success of the -9. It's the variant that works, but it's not the star, and this is where rivalry matters. Airbus watched Boeing's composite gamble and responded with the A350XWB, 53% composites by airframe weight, clearly influenced by the 787's pioneering approach. The A350 arrived later, entered service in 2015, and benefited from watching Boeing's mistakes. Airbus kept more production in-house. They avoided the outsourcing nightmare, and they built an airplane that competes directly with the 787-9 and the 777 in various configurations. But here's the nuance. The 787 didn't just create a competitor, it created a category. The efficient, composite, twin-engine widebody capable of point-to-point long-haul service. Before the Dreamliner, this category barely existed. Now it's the most important segment in commercial aviation. The 787 also killed its own siblings. The 767 effectively died because of it. Orders for new 767s evaporated once airlines could buy a Dreamliner that burned 20% less fuel. Even the 777 felt the pressure. Why buy a bigger, thirstier airplane when the 787 could serve a similar route at dramatically lower cost per seat? The 787 proved Boeing's original thesis correct. The future wasn't about bigger hubs and bigger airplanes. It was about more routes and smarter airplanes. Airbus built the A380. Boeing built the 787. The A380 production line shut down in 2021 after 251 deliveries. The 787's backlog extends years into the future. Boeing won the argument. They just nearly went bankrupt proving it. The 787 remains in production today, with Boeing targeting a rate of 7 to 10 aircraft per month by the mid-2020s. The platform is expected to remain in production well into the 2030s. Its influence extends far beyond a single airplane. Composite construction, more electric architecture, advanced cabin environments. These aren't innovations anymore. They're expectations. Every new airplane program that launches from this point forward will be measured against the standard the Dreamliner set. But the 787's most enduring legacy might not be technological, it might be cultural. It taught the aerospace industry that you can't outsource your soul, that the cheapest way to build an airplane is rarely the best way, that financial engineering is not the same as real engineering, and that when you hollow out the people who know how to build things, the things you build will eventually break. The Dreamliner changed the map. It connected cities that had never been connected. It gave passengers a cabin that didn't punish them for crossing an ocean. It proved that composites could replace aluminum at scale, and it showed the world exactly what happens when a company tries to build the future on a spreadsheet instead of a factory floor. So here's the question: was the 787 worth it? it. $32 billion, 7 delays, a fleet grounding, a quality crisis, years of losses on every airplane delivered, and yet 1,800 orders, 1,100 deliveries, hundreds of new routes that didn't exist before, an entire category of aviation that it invented. The Dreamliner didn't just change Boeing, it changed what it means to fly. And every time one of them lifts off, carbon fiber flexing, those massive engines humming, cabin light shifting from amber to blue as it climbs through 40,000 feet, it carries the weight of every mistake, every dollar, and every lesson it took to get there. That's not luck, that's the most expensive education in aviation history.